Second part is about which 3D printers we have, what's the difference between them, and how to use them. So in the lab, we have two fuse deposition modeling, one stereolithography, that it's the Form 3, and two mask stereolithography. So what's the difference between all of them and why we are using them? Those are the classical one. So this one, it's practically a workhorse, but the build plate is quite small. So we have a new one for larger or bigger prints. The Form 3, that is a stereolithography printer, we are using really when we need some precision. So for example, for the master of microfluidics, we will use the Form 3. And then we have something for developing. Those one are the mask SLA. For example, for the Anycubic, there is someone with the microphone that it's giving problem. Maybe. No, not anymore. So the Anycubic, it's really fast and cheap. So we are using for developing our own resin or also the machine itself. So this iodamine rhodamine was printed with this one because if you break it, it's not a huge deal. If you break the Form 3, it's already a little bit more painful. So how do they work? The FDM are the easiest one. They work just by melting plastic. So you have your filament, it's passing through a heated nozzle, it melts the plastic, and then it deposits layer by layer. There is one main difference, and this is why also we have two of them. It depends on how they drive the filament around. So one is the direct drive. So you have the motor exactly on top of the print head, and this one drives the filament inside. The other one, it's a Bowden tube. So the motor for driving the filament, it's outside of the printer. Then you have a Teflon tubing that brings the filament near the hot end, the print head. So there are pros and cons of both of them. So for example, the Ultimaker, the motor for driving the filament, it's outside, it's on the back. This one, the motor is already on top of the print head. So this one, usually it's a little bit more reliable and you can print a lot of different filament with this one. But the print head, it's heavy because you have the motor on top as well. So it's usually slower than the Bowden tube. So this is the hot end of the printer. This part here is the heating block. So you can see two different cables coming from here. This one, the big one, it's for increasing the temperature. So the temperature, and the small one is the temperature control. The top part, usually it has a fan on it, like this one, because in this part here, you want your filament to be still filament-like. Because if I have molten filament around here, it's really difficult to push it through. So I want to melt the filament only in this small part here. So this part is still the cold part, and this one is the hot end part. Then you have the nozzle. The nozzle are interchangeable, so I can remove this one and put a new nozzle. And this one was a Bowden tube. So this one is, there is still some filament inside. This one is the Teflon tubing. So there is no motor here. The filament is driven by far away. This is one. You can print a lot of different materials with this one. Mostly we are printing in PLA or ABS, but there are quite a lot of filaments that you can print with one. One thing to take in account is that you are printing molten plastic. So if you have a design like this one, at this point here, it's going to be really difficult to print because there is no support supporting this molten filament. So we are printing from bottom to the top. When you arrive at this point, you are practically extruding molten plastic in air, and this is not going to work. So when you are printing something like this, either you need support, so other plastic that can support this part here, or you just print at an angle. That's the easiest thing. Then we have the SLA that are using a laser. And this is the Formlab. It works on a vat full of resin. here you have your liquid resin that is 99% made out of acrylates. And on the bottom, you have a laser that photocures this resin. So you harden the resin just by shining a light laser of 405 nanometers. And you have the stage, that is this part here on the form, and this stage is moving upwards. So I first cure the first 25, 50 microns of resin. I pull out the stage, pull up the stage, and then I cure another 50 microns, and so on and so on. So those ones are using laser, and this is why they are so precise. Recently, we got also masked SLA. It used the same principle, but instead of a laser, is using LAD. So a rack of LAD of 405 nanometers. You are shining the laser, and then you have an LCD that works as a mask. So if I have an LCD here, the LED are always on, but I'm using my LCD that will be either black or transparent for photocuring part of the resin. This means that it's way faster than the laser because there are no moving parts. And it's usually also more flat than the laser because I don't have the moving part of the laser. I just have a single LED array that shines light. They are using 3 different programs for preparing 3D design to be printed, and we start with the Cura. That it's the one that we use usually for FDM printer. This is how Cura looks like. And here, the first time that you open it, you need to choose which printer you want to use. This is a program made by Ultimaker, so usually the Ultimakers are already here. And then you need to add some other printers that are not Ultimaker. So this is the Ultimaker. The other things you need to choose is which nozzle are you using and which material are you using. So the one that we have now in the lab, it's with 0.6 millimeters, so 600 microns. And again, usually we use PLA. The quality of the print, this one, it's in profile. And you need to choose how good your print will look like. So this one, it has layer of 200 microns. So the first thing that we do, it's putting our design on here. And then we choose something else. So if you're using the Ultimaker, everything should be already set. I want just to show you something a little bit, or how to set it up. So if I click on slice, it's already preparing the design to be printed. So I click on preview, and this is how it looks like, layer by layer. So this one, it will be 49 layers, and I can click up and down with layers. So you can see this is the first layer. It makes two different, it makes, first of all, the base. So everything here, it's full. The red lines are the outer part, and the blue lines, it's how the printer starts. So it starts from the outside. This is not part of your design, but it's just for making the plastic flow in the nozzle a little bit. So for purging a little bit the nozzle. Then you can see that here we start having support, because I didn't show you in this setting, we will go later. There is support for supporting the overhangs that are those parts here. So this plastic here will not be, will be printed, but it's not part of your design. It's here only to support the initial part of the whole. Then you go on top, and this is your design. This is how it's going to print your design. Let's change something. For example, I want this one to be watertight. And to be watertight, I want more perimeters to be sure that it's watertight. So the wall line count, it's how many times you will have a wall around. So now it was 3. I can put, for example, 6, that it's a double. I need to slice it again for checking how it looks like. And now you can see that the outer wall, that it's this green part, it's 6. So it will pass 6 times around those walls. And this should give me a proper watertight. I can change the infill, that it's the yellow part. Now it's 50%. I can change it, for example, for 20. I re-click on, and now this one, you can see that it's a little bit whole. But again, if I'm going for something heavy and to be sure that it's printed properly, either I go for 50% or even 100% if I want to be sure that nothing is passing through. But this should be fine because we have 6 walls. And this is the infill part, the shell part, quality, it depends on layer height. Infill material, it's everything set up directly by the 3D printer, by this profile. Print speed also don't change anything. Here don't change anything. Support. So this is part of support. I can click generate support or don't generate support. And if I now redo it, you should see that the support is going. It's gone. Hey. All right, now it's printing without support, which usually is necessary for finishing. And honestly, the circle should be easy printable with this circle. All right, other parameters that you want to check. So this one was the support, the build adhesion, the build plate adhesion. So this one, this blue part here, it's called the skirt, and it's just for having a proper flow of molten plastic. But there are different things. For example, the brim is also sometimes very useful. What the brim does is creating this kind of support, well, not support, but external perimeter around your design. So if you have problem of sticking your design on the build plate, or you think that it's not stable enough, you can print a brim. So for example, if I'm crazy and naturally you can move this around, you can tweak, you can shift it and wherever you want. If I'm crazy and I want to print this in this direction, because I'm crazy and I want to print it in this direction, this one will never be printed because you have a single attach point on the build plate and this part will not be stable. If I want to increase my luck and I have to print something very difficult, then I can print a brim. And the brim, it's only increasing the area of this part to the build plate. So this one is still impossible to print, but I have better chance to put this one, the brim, on the print. Another things that you need to consider when you are doing this job is how the printer works. So this one, those printer work always layer by layer. So if I print in this direction and I try to bend it after it's printed, it's easier that you break it because you have layers in this direction. So it will be stable, but not so stable if you try to bend it in those direction, because you can just simply break those points. If you want to have stable in that direction, it's better to print it in this version. So the layers are in this direction. Now, if you try to bend it, it will take way more force than if you print it in the other direction. That always depends on how the layers are printed. Let's say that we are done. I don't want the brim for this one. I want the skirt. You slice it and you save to file. This one, it's a G code. Once you have saved it, you save it as a G code, and this one, it can directly go on the Ultimaker or the other one. So you just save it as a file, you upload it on a SD card for Ultimaker or a USB stick, and you can just go there and print it. These are actually kind of easy peasy. There are a lot of things that you can change, but it's a little bit more complex. So this should be the easy part for print it yourself. Then we move on the other one, that it's the Preform for printing with Form 3. And this is how it looks like. Naturally, every single program has a different way of moving things around, but it's quite annoying. Where is it? This one. This is our design for the 3D print for the Form Lab. So this is the build plate. This is our design. And most of the time, you can just click here, and it's one click print. I didn't set up my print. But usually it translates, it moves to 45 degrees because that's the easiest way to print on those printer, and creating support, because on those printer you always need support because of the resin. Okay, and this is your print with support. And there are only a few things that you need to change here. It's which kind of printer are you using, which material are you using, and which layer height you want. So this is a program specially designed for this printer, so everything is practically already here. The material is here, the layer height, there is nothing enough to change. The only important things is that if you print it in this direction, most of the time works, but the surface will not be completely flat because you will have all the layers in this direction. So when we are printing something for microfluidics, we actually print it flat. So you put this one, I'm at completely flat on the bed plate. We still use the support because then it's easier to remove it. But if you put it completely flat, you will not see the different layers. So you will see only the layer moving. This is why it's opaque. But this is the way to go if you want to print something flat. We again use the support, but practically that's it. All right, that's it. You can just for using this one, either you put it on your computer and you save it, or you do it directly on the computer that it's in the printing room. That one is already connected to the printer, because this printer doesn't have a USB stick or SD card. You need the computer to bring the file to the 3D printer, internal memory. So you need the computer attached to the printer. Or Wi-Fi, but we don't have Wi-Fi. All right. And this is the second one. Then there should be Chitubox. For Chitubox is the same thing. So I again put my file here. This is probably too big for this printer. It is. But again, you can move and shift wherever you want. You can have different settings. This. Okay. 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 Finally. So this is actually too big to be print on this this printer. But here is where things get complicated, because those are first of all kind of new printers, and second of all you can use a lot of different resins, and the resins are a huge problem, because you have amount of light that they need to be that you need to shine for photocuring it. You have different light off, so for cooling down the resin, because when you do this reaction, usually you reach more than 100 degrees. You need the lifting distance, so how far away the top part should raise before starting a new layer. This is quite complex. So when we do a new resin, let me delete this one. The first thing that we do is printing a validation test. So this is the so-called validation test for the resin printer. It has a lot of different features, both positive features and negative features. It has a slope for checking how the layer height should be. And again, those one are negative features at different angles and positive feature at different angles. So when I want to test a new resin, I usually print this one, and I change most of the time the exposure time per layer. So I start with either 3 or 4 seconds because it also depends on the layer height. If I want to cure something at 25 microns, it's different if I want to cure something at 100 microns. So how much light, how much time I need to shine the light for curing this layer. There are two things that can happen. One, if you overexpose it, the negative features are not coming up. Because if you overexposed, it means that you are curing the resin inside, even if you don't want to. This is overexposure. And underexposure, if you are not curing for enough time, you will not be able to see the positive features because you are not curing it enough. So the smaller one will not get as much light for curing. Those are the only things that I want to say about this printer. And practically that's it also for this part here. Let me go back here. You are free to use whatever printer you want. Only the first time that you are doing this slicing, come either to me or to Sander for checking if everything is correct before starting. That's the only things I ask. Once we are sure that you know how to do it, then feel free to use practically any printer that we have in the lab.